Our topic for today is about recursive sequences, focusing on how to get the formulas. What is recursion? Recursion is the process of choosing a starting term and repeatedly applying the same process to each term to arrive at the following terms. Recursion requires that you know the value of the term immediately before the term that you're trying to find. So the first type of sequence is the arithmetic sequence. The difference between the consecutive terms is constant. That means that you must add or subtract the same number to the term to get to the next term. For our example, 22, 16, 10, and 4, we are going to treat this as recursive, meaning 16 needs 22, 10 needs 16, and 4 needs 10. So how is this done? So let us derive the formula. Well, first of all, let us examine the difference between 22, 16, 16, 10, and 10, 4. The way to do it is you're going to go to your second number and you're going to subtract them, which means 16 minus 22, 10 minus 16, and 4 minus 10. That is always the process. So please remember that. The new number minus the one preceding it. So let's solve this. So this now is a negative 6, this is a negative 6, and this is a negative 6. Therefore, the difference is constant. The common difference is a negative 6. And we're going to denote that by the letter D equals negative 6. So how does this work? Let us examine this. I will call this my A1, this is my A2, this is my A3, and this is my A4. Let us pretend that we do not know our A2, but we know our A1. So how will we get A2? So let us start exploring how to get the formula. So if I have A2, since this is a recursive formula, I need the number before it, which is my A1. And what did I do with my A1, which is 22, to get to 16? You're right. I added a negative 6. Now, let us put our A1 here. So my A2, pretending that we don't know our A2, is now equal to our A1 is 22, plus negative is the same as minus 6. So my A2 is 16, which is accurate. You have 16 there. What we're doing right now is we're just exploring how to derive the formula. So later we're going to have our own derivation of the formula. So now another exploration is, what if I'm looking for A3? If I'm looking for A3, I need my A2. And again, if I'm at 16, how do I get to 10? By adding the common difference. So plus negative 6 again. Therefore, my A3 is, we have to know the number previously before A3, so that is a 16. And then plus negative is minus. So my A3 is a 10, which is accurate. It's a 10. Okay, after all these explorations, can you now find a way on how you can express AN? Let's say you're looking for any term, and we are going to denote that as AN, because this is ... AN. Okay, so how will that be? If this is a 2, I need my 1. If this is a 3, I need my 2. So if it's an N, how can I express it? So A to the N minus 1, because it's always 1 less than what you're looking for. And I hope you get that. And then you're adding the common difference of D. Therefore, this is the formula for our arithmetic sequence on recursive. So, let us go ahead and start using the formula. What if I use the same sequence, but I will look for my A5, A6, and A7. So let us do this. If I'm looking for A5, I need my A4, which I will have to add to my D. So I have my A5 and my A4 is 4, and my D is a negative 6. So now my A5 is negative 2. Box that. We're not done. We need to look for our A6. So our A6, I need my A5, which I will add to my D. And my A6 is equal to negative 2 plus negative 6, which my A6 is a negative 8. Now, A7. I need my A6, and then I need to add my negative. I need to add my D, which now I will have A7 equals negative 8 plus negative 6, which A7 is negative 14. Okay, so for our next type of sequence, we are going to discuss the geometric sequence. So what is geometric sequence? Geometric sequence is a type of sequence where the ratio between the consecutive terms is constant. So now it's no longer the difference, but it's the ratio. So what's ratio? The meaning of this is that you must multiply or divide the same number to the previous term to get to the next term. So as you can see, 5 became 15, 15 became 45, 45 became 135. And you're right, we're multiplying by 3. So this is a geometric sequence. We're going to treat this as a recursive example because we want to derive the formula of a geometric sequence under a recursive sequence. So again, this is easy. So now we know that we're multiplying by 3. But what if it's not the simple numbers that you're seeing here? So what do we do to find out what we're doing with 5 to get to 15? There is an exact way to do it. And the exact way is get to the second number and divide it with the first one. So how this is going to happen is you will have 15 over 5. And for this one, you will have 45 over 15. And for this one, you will have 135 over 45. And as you can see, all of them will have a 3, a 3, and a 3. And that's multiply. So we're multiplying by 3. And this now is called the common ratio. And the common ratio is a 3. And the common ratio is represented by the letter R. So let us begin deriving our formula. So once again, I'm going to call this my A1, this is my A2, this is my A3, this is my A4, and our goal is to really be able to know how to find our AN eventually. Okay, so let us begin. Recursion requires that you know your previous number before you can go to the next. So let's pretend once again that we don't know A2 and we're looking for A2 and the one that we know is A1. So if I'm looking for A2 and I have my A1, all I need is to multiply that A1 by A3. So I need that to be multiplied by A3. So now my A2 is 5 times 3. My A2 is 15, which makes sense because that's 15. Okay, how about we look for A3? If I'm looking for A3, then I need my A2. And my A2 is 15. So, sorry, let's put A2 so that we see the pattern. A2, and I need my 3. And so my A3 is, A2 is 15, and I need to multiply that by 3. So I will have A3 equals 45. Now, let us look at this pattern. My A2 needed my A1. My A3 needed my A2. So deriving the formula, if I have AN, what must happen to N? Very good, you're right. I want an A sub N minus 1 because what I'm looking for needs the term before it. So this means you are going to the term before it. So minus 1. And then you're going to multiply by your R. So this now is the formula. However, just to fix this, we're required to put this in the front. So we're going to put or AN is written this way. R in the front times A sub N minus 1. This now is pretty much the same as our formula for the arithmetic sequence, except that this we are multiplying a common ratio. So, let us begin some exercises. What if I'm looking for my A? I would include the 4, even if it's there. So A4, let's have A5, and let's have A6. Okay, let us begin solving. So if I'm looking for my A4, I need my A3, and I need to multiply that by my common ratio, which is R. And I'm sorry, I'm putting my times 3 on this side. It is commutative, so it's actually the same. However, the formula requires that we put it in the front just so it's not confused by this notation right here. So we are doing that, or you know what? Let me go ahead and do it correctly. I mean, the right way, based on the formula. So 3 in the front times my A3 is 45. So my A4 is 135 if you multiply them. Good job on that one. All right. Let us now, I'm going to write it down here. So I'm looking for A5. My A5 is, okay, so it says R times. So 3 times I need my A3 and my A5. So I'm looking for my A4. I'm looking for my A5. So I need my A4, which is 135. And 135 times 3 is 405. It's my A5. And my A6 is 3, which is your R, times your A5, which is 405. And so my A6 is 1,215. All right? So good luck on your exploration on recursive formulas.